right, so example number 1, we have the loaded cab of an elevator has a mass of 3 times 10 to the third kilograms and moves 210 meters up the shaft in 23 seconds at constant speed. At what average rate does the force from the cable do work on the cab? So here they're not asking you for what the work done is, they're asking you for the average rate of work, aka the power, because we know power is the rate at which work is done with respect to time. So let's write down our givens and draw a free body diagram. We have a mass of 3 times 10 to the third kilograms. We have a displacement, I'll call that D, equal to 210 meters. And then we have a time of 23 seconds. Now, we need to draw a free body diagram because we know that since this is going at constant speed, that applied force by the cable is going to be equal to the force of gravity or the weight of the elevator. So that means applied force will be equal to force of gravity, which is m times g, which is equal to 3 times 10 to the third kilograms times 9.8 meters per second squared. So what we get here is 29,400 newtons for our applied force. All right, so we know that power is what we're looking for, and that is work over time. If we insert our work equation, we get force times displacement times the cosine of theta over time. Now, of course, our displacement and our force are in the same direction, so that angle in the cosine theta is going to be 0, and I know that cosine of 0 is 1. So really all we're looking at is force times displacement over time. So what we get here is power is equal to the force, which we just found to be 29,400 newtons, times displacement, which was 210 meters, divided by the time, which was 23 seconds. So we get 268,434 watts. 0.8 watts. And there is our answer. Of course, if we divide this by 1,000, we can get this in kilowatts, but of course it's all the same thing, just different units.